Welcome. In this video, we are going to review the workflow to manage the SmartServer IoT using the IzoT commissioning tool. In this workflow, IzoT CT handles all the device commissioning, connections, configurations, adds, and deletes. In a CT managed network, the SmartServer IoT must be configured to operate in independent mode. The integrator plans his IzoT CT design so as to organize subsystems for devices that will be exported to individual SmartServer IoTs. A net export utility is used to convert the CT database into an image that can be used by the SmartServer. This utility is run each time changes are made. Creating, deleting, and replacing devices must be done in CT. It's important that the SmartServer be in factory condition. Here we are using a serial console session in PuTTY to execute the Apollo reset. We're providing two parameters, normal and also a simple password. Remember that in the initial software release there is no password recovery mechanism, so keep this password in a safe place. The complete reset process will take roughly 8 minutes. This video was recorded with the PC and the SmartServer directly connected to ETH0. With no DHCP server present, the SmartServer will self-configure to a 192.168.1.222 static address. To communicate, the PC must be on the same subnet with unique address. Regardless of how the address is assigned, the back of the SmartServer gives us information about the host name that's been assigned to the SmartServer as well as the login credential for the Apollo user. To test out access by host name, we'll go ahead and use ping. We'll end the host name in .local so that MDNS is engaged. Now we are ready to start a browser, use this address in the address bar, and access the configuration pages for the SmartServer. We'll log in as Apollo using the credential on the back. Once we're in the configuration UI, we click on the Features tab and enable the RNI channel that will be used for the connection by IzoT CT. In a larger network, we would likely enable the IP852 channel or extend the IP70 channel outside the box. In this particular example, we're just going to enable the RNI and LAN scanner interfaces. With the RNI resources enabled on the SmartServer, we can go ahead to the LANWorks interfaces applet and add the interface to access with OpenLDV and the IzoT CT stack. I'm using the hostname.local to address this device, knowing that even if the network conditions change, as long as my PC and the SmartServer are on the same subnet, hostname.local should resolve with MDNS. A large system may have dozens of SmartServer IoTs. In the next series, we'll go ahead and enable the IP852 channel. First, we have to enable the feature in the SmartServer configuration. Then we have to use the configuration server to enable the device on the channel. Finally, we'll define a VNI device that can be used by our network management tools. We are back in the SmartServer configuration UI. We go ahead and click on the Features tab so we can enable the IP852 channel. Don't forget to click the Update button after selecting the option. Once enabled, we can go to the IP852 channel config server and add this device to the channel. Again, we are using the hostname.local to add the device. After the device is added to the channel, a short while later, the config server will update it and the device will turn green. A VNI network interface must also be defined on the channel. We do this in 2 steps, first in the config server, and then finally in the LANWorks interfaces, we have to define the device there as well. Once it's defined in LANWorks interfaces and all the devices on the channel are green, we are ready to start our work. Let's start up the LANWorks interfaces 32 and go ahead and add the VNI device and test it to make sure that it's connected to the channel configuration server. In the next sequence, we will engineer the network in IzoT CT. We start by creating the network and attaching ourselves to one of the interfaces we've just defined. We add channel and routing infrastructure that is inside the SmartServer. We plan our subsystem structure for the export operations. In our export subsystem, we will add our devices to our network and also include an internal SmartServer device that will access the exported devices for monitoring control by the SmartServer. Now we will launch IzoT CT. We're going to create a new network, and we're going to select one of the interfaces that we've previously defined in this video. We're actually going to use the VNI device in this case. We're going to click through the startup screens and make sure we come up as attached and on net. First, we start building out the channels that we will use in our system. Verify that the backbone channel is configured to be IP852. If not, set it this way. Next, we need to define an internal channel IP70 that is used to route between IP852 and any of the 1 to 4 network interfaces that may be attached to the SmartServer IoT. Finally, we add the channels for each of the U60s attached. In this case, there's just one. We're going to call it FT1. With the channels created, we can now define the routers that move packets between the different media. Next, we're going to add a subsystem that's going to contain the devices that will be exported with the Net Export tool. In a large system, you will need to replicate this structure many times, once for each smart server that's in the system. With the foundation in place, let's drill down into the export subsystem and create our network. First, we're going to add the channels or references to the channels that are part of the top-level subsystem. We add the FT1 channel as well as the internal IP70 channel. Next, we're going to create 2 devices. These are simple multi-sensor examples. We'll provide a link to these so you can try them out for yourselves. They run on an EVB 5000 or 6000 platforms. And finally, we're going to add an internal SmartServer IoT device that is going to be the actual agent that manages these devices on the SmartServer IoT. With our system designed, it's time to start commissioning. Let's pop back up to the top-level subsystem and start to commission the internal devices on the smart server. We have to work our way out from the network interface. We start with this router, right-click Commission. Then we go to the smart server configuration pages in order to assert the service pin. Repeating this process for the internal IP70 router, but in this case we press the service pin from the system page of the configuration UI. We next drill back down into our export page and select the internal smart server device and commission it. In this case, from the smart server configuration UI, we use the system page service connect button to generate the service pin. To finish out the commissioning steps, we select our 2 target devices and commission them. We'll use service pins, and we'll also request that the applications be downloaded because we're not sure what's inside these particular devices. To round out this exercise, we need to create some LOMWORKS connections. Let's start by adding the function blocks from these multi-sensor devices. We're going to add the lamp actuator and the switch sensor devices and create some pure connections between them. Here I've created a LAN scanner connection to the Layer 2 RNI device inside the smart server so we can prove out the fact that these peer connections are actually working. You can see the traffic between the 2 switch devices here. The iNet export utility is a compiled run-in-place Node.js console application that is used to export parts of an IzoT CT database to a form that can be accessed by the SmartServer IoT for monitoring and control. Let's have a look at the command line parameters. First, there's the network name. Second, the target subsystem that has the devices that need to be exported. Next, the protocol and the target smart server along with the install code information is necessary. Finally, we specify the direct connection, and the V option gives us a verbose report of what's going on. Before this can work, we need to open a smart server port up at port 1883. To open the firewall, we'll log in with an SSH connection to the Smart Server. We're going to use the sudo command to elevate our privileges, then access the firewall to allow port 1883 to go through. For net export to work, the Smart Server must be in independent managed mode. We're going to set that up right now. We click on the CMS tab of the configuration UI and are presented with the CMS login. We use the username Apollo and the credential on the back or the one that we set. We're going to start out by tidying up the interface a little bit just so we see the widgets that we need. In the Devices Widget Action menu, we will select the option to put the Smart Server into independent managed mode. It's a good practice to have the iNet export command string as a text box in your Visio drawing so it's as easy to access in the future. We're going to go ahead, open a command box, and run iNet export. Remember, success here requires you have checked all the boxes. The Smart Server in independent managed mode, all the devices in the export system are commissioned, and port 1883 has been opened on the Smart Server. We will now verify the results of the iNet export. You can see in the CMS that the two devices are defined, and I can do operations like test and wink to verify their operation. These devices are now ready to be accessed by the Smart Server CMS. Here's a quick recap of the IzoT CT workflow for the Smart Server. First, we enable IP852 and RNI features in the SmartServer IoT. We use the Longworks Interfaces 32 control panel applet to add the interfaces so they can be accessed by external tools. We use CT to add the Smart Server routers and channels. We organize our resources for export into a single subsystem. We place the Smart Server IoT in independent managed mode, use the export facility to convert the database, and then verify the results in the CMS. I hope you found this useful. Thanks for watching.